Trig functions and triangles. So I want to take a look at a right triangle, and specifically I want to take a look at theta, one of the non-right angles. And that non-right angle is formed by one line segment here, the base of the triangle, that is adjacent to it. So we'll call this the adjacent side. There's also a side across from the angle theta. We'll call that the opposite side. And then, of course, the longest side, the one across from the 90-degree angle, is the hypotenuse. With these sides, we can define functions of the angle theta. So we can feed these functions the angle theta, and the function would output ratios of these sides. So let's go ahead and name these functions. The first one I want to look at is the sine function. The sine function is the function that takes the ratio of the opposite side of theta and the hypotenuse of the triangle. And the sine theta is just that ratio, the opposite over the hypotenuse. This is the spelling of the sine, and this is the abbreviated version of the function, with the independent variable theta and the output being the ratio, the opposite side over the hypotenuse of this right triangle. We can also name another function based on the adjacent side and the hypotenuse. That function is called the cosine of theta, and it's the ratio adjacent of theta to the hypotenuse of the triangle. And then the other one is going to be the ratio of the opposite and the adjacent. So this is the third trig function. It's called the tangent of theta. So the tangent of the angle theta is the side opposite theta divided by the adjacent side to theta. These are the first three trig functions. The last three are just the reciprocals of these. So the first reciprocal is the cosecant, which is the reciprocal of the sine. The second is the secant, which is the reciprocal of the cosine. And the third is the cotangent, which is the reciprocal of the tangent. So these are the 6 trig functions. We're going to go ahead and define these for a specific triangle. But before we do that, I want to look at an equilateral triangle that has sides equal to 2 units. All the angles are equal to each other, all the sides are equal to each other. What I'm going to do is I'm going to drop an altitude from this top angle to this bottom side. The bottom side is 2 units long, just like all the rest. The top angle is 60 degrees, just like all the rest. But when I drop an altitude, it's going to cut that 60-degree angle in half, making this half 30 degrees. It's also going to cut this side in half, making this half 1 unit. This creates a right triangle, this right triangle here. And if we focus on this angle theta here, we can actually define the 6 trig functions. But I first need to know this unknown value x. So I'm going to use the Pythagorean theorem to do that. The Pythagorean theorem says a squared plus b squared is c squared. And that means that 1 squared plus x squared is equal to 2 squared. The hypotenuse is always c. We go ahead and we square both. We get 1 squared plus x squared is equal to 4. And then we subtract 1 from both sides to get x squared is equal to 3. And then we can go ahead and take the square root of both sides of this equation. We'll get x is equal to either positive or negative 3. But we're talking about the altitude of this triangle, so that's equal to the positive square root of 3. So now we can define the 6 trig functions for the angle. For this 60-degree angle, we'll have the sine, which is equal to the opposite over the hypotenuse, square root of 3 over 2. We'll have the cosine, which is equal to the adjacent over the hypotenuse, 1/2. We'll have the tangent, which is equal to the opposite over the adjacent, square root of 3. And then we'll just flip these over to get the cosecant. So the cosecant is the reciprocal of the sine. So that's going to be 2 over the square root of 3. When you rationalize it, you get 2 square roots of 3 over 3. Then we're going to look at the reciprocal of the cosine, which is just 2. And then lastly, the reciprocal of the tangent, which is the cotangent. You flip it over, you get 1 over the square root of 3, but then you rationalize it to the square root of 3 over 3. We can tilt this and flip it around and put the 30-degree angle where the 60-degree angle just was, and then find the 6 trig functions now for a 30-degree angle. So let's go ahead and find them. Well, the sine would be equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, but then you have to rationalize it. So you get 1 over the square root of 3, but then you multiply the top and bottom by the square root of 3. So the final answer is square root of 3 over 3. Then we have the cosecant, which is the hypotenuse over the opposite, the reciprocal of the sine. The secant, which is the hypotenuse over the adjacent, the reciprocal of the cosine. And the cotangent, which is the adjacent over the opposite, which is the reciprocal of the tangent. And there are the 6 trig functions for a 30-degree angle. One last specific triangle to look at here, and that one is the 45-45-90 triangle. If you have a 45-45-90 triangle, that means it's an isosceles right triangle we're looking at specifically here. And this isosceles right triangle has 1 unit for the base and 1 unit for its height. We can use the Pythagorean theorem to find the other side, the hypotenuse. A squared plus b squared is c squared, which means 1 squared plus 1 squared is the hypotenuse squared. We square the 1's and we get 1's. We add those 1's and get 2. And then we take the square root of both sides. We'll get x is equal to either positive or negative square root of 2. But of course, we're looking at the positive one here. So this is the triangle we're looking at. And we can look at either 45-degree angle, it doesn't matter. So when we say opposite over hypotenuse, that's 1 over the square root of 2. When rationalized, it's the square root of 2 over 2. The cosine is the same. The tangent is 1 over 1, opposite over adjacent. And then we just flip these over to get the other 3. So the cosecant is this hypotenuse over the opposite. The secant is the hypotenuse over the adjacent. And the cotangent is the opposite over the adjacent over the opposite. So these are the standard angles: 30 degrees, 45 degrees, 60 degrees, and also 0 and 90. So you have to remember these numbers. And there's a kind of easy way to remember it. There's a table you can make to remember these. So here's the table. So we have the angles across the top. These are the standard angles in the first quadrant. Well, the first 0 degrees is a quadrant angle, and so is 90 degrees. Those are quadrant angles. But these 3 are in the first quadrant: 30 degrees, 45 degrees, and 60 degrees. And we just did those triangles that told us what the sines and cosines and tangents and all the trig functions of these are. Here's an easy way to remember the sine and cosine, at least. You make this table, and then you start with the square root of 0, the square root of 1, the square root of 2, the square root of 3, and the square root of 4, all divided by 2. And then for the cosine, you go backwards. Square root of 4, 3, 2, 1, 0, all divided by 2. And then you simply simplify all of them. And we get these as our trig functions. And then to find the tangent, you simply divide the sine by the cosine. So for instance, the tangent of 0 degrees is 0 divided by 1, which is 0. The tangent of 30 degrees is 1/2 divided by the square root of 3 over 2, which is the square root of 3 over 3. The tangent of 45 degrees is the square root of 2 over 2 over the square root of 2 over 2, which is 1, and so forth. So to find the tangent, you can simply divide the sine by the cosine. So that's a quick little mnemonic you can use to remember well, at least the sine and the cosine. So let's look at some examples of these triangles being put to use. All right, so here's a sign you sometimes see on the road if you're in a mountainous region. It tells you the grade. So this road has a 35% grade. So a truck travels 4 miles along a straight road with a 35% grade. What is the truck's change in altitude? Okay, so let's first calculate the angle of the grade. There's a formula we can use that says that the angle here of the inclination, the angle that we're looking for, is the arctangent of the grade. Since this is a 35% grade, in order to find the angle that the truck is climbing up, all I have to do is find the arctangent then of 0.35, 35%. And when I plug that into my calculator, I get that theta is equal to roughly 19 degrees. So I have a trucker going up a 19-degree incline, and it goes a distance of 4 miles up that 19 degree incline. And what I want to find is I want to find the y value, or the change in altitude. I want to find how high it climbed if I know it went 4 miles along that straight road. So all I need to do then is solve this triangle. And I'm going to use a trig function to do that. All I have to do is consider which trig function involves these two sides for the angle 19. So which two trig functions involve the opposite and the hypotenuse of the 19-degree angle? Well, I could either use the sine of 19 degrees, which would be the opposite y over the hypotenuse, or I could use the cosecant of 19 degrees, which would be the hypotenuse 4 over the opposite y. I prefer the one that has the y in the numerator, so I'm going to use that trig function to solve this word problem. Let's see. Next thing, I just need to solve for y in this equation, and that'll tell me the change in altitude for the truck. So I'll multiply both sides by 4, and that'll give me that y is roughly 1.3 miles. I just type this into my calculator. 4 times the sine, 4 times the sine of 19 degrees. You have to make sure you're in degree mode. Will give you roughly 1.3 miles. All right, let's define some words now. A definition that I want to make here is the definition of an angle of elevation. An angle formed by a horizontal line of sight to an object that is above horizontal is called an angle of elevation. So if we start with a horizontal line of sight, but then we look up, that angle that our line of sight has moved through is called an angle of elevation. So, an angle of elevation from the horizontal. Let's take a look at an angle of elevation example. A tree that is 50 feet tall casts a 120-foot shadow. Find the angle of elevation of the sun to the nearest degree. So they're giving me they want me to find the angle of elevation. They tell me that this is a 50-foot shadow, that the tree is 50 feet tall and it casts a 120-foot shadow. And they want me to find this angle here. So they want to find the angle of elevation, which is above the horizontal to the sun. Okay, so they're giving me the information that the tree is 50 feet tall and is casting a 120-foot shadow. So that's what I need. I need to just look at this triangle and figure out how to find theta. So I need to figure out which trig function I can use to relate the opposite and the adjacent of the angle theta. And there are two trig functions we can actually use here. There's the tangent and the cotangent. We could use either one of these, but I'm going to go ahead and use the tangent because I have a calculator that can do the inverse tangent function. It can take the output of the tangent and bring me back to the input. So since I know the output of the tangent is 50 over 12 and I want to know the input theta, I'm going to go ahead and use the arctangent function to find theta. So the arctangent or inverse tangent function will give me theta if I give it the output for the angle theta. The output for the angle theta is 50 over 120 or 5/12. So I just take the arctangent of 5 over 12, type that into my calculator, and it'll give me roughly 23 degrees. So the angle of elevation to the sun is 23 degrees. All right, so another definition is an angle formed by a horizontal line and the line of sight to an object that is below the horizontal line is called an angle of depression. So the angle of depression is formed when you look down from horizontal. You look down. All right, so look at an example here. All right, sighting the top of a car, the angle of depression of an observer on the roof of a 150-foot building is 30 degrees. How far is the observer from the car? All right, so they're telling me that the angle of depression, or the angle below horizontal, for the observer is 30 degrees, and that the building is 150 feet tall. And they want to know how far the observer is from the top of the car. So we have this triangle here. Now we have to think about which trig functions are going to allow us to solve when we have the opposite and hypotenuse for a 30-degree angle. So let's think those trig functions could be the cosecant of the 30-degree angle equals the hypotenuse, which is x, over the opposite, which is 150, or the sine of the 30-degree angle equals the opposite, 150, over the hypotenuse x. I once again prefer when the variable is in the numerator. It makes it a little bit easier for me. So I'm just going to go ahead and use the cosecant. And if I'm using the cosecant, then I'm just going to multiply both sides of this equation by 150. And now I have that x is 150 times the cosecant of 30 degrees. The cosecant of 30 degrees is 2. It's the reciprocal of the sine of 30 degrees, which is 1/2. So we get that x is equal to 150 times 2, and x is 300. So that means that the distance from the observer to the top of the car is 300 feet. So an arborist measures the angle of elevation to the top of a tree from 50 feet away and finds it to be 30 degrees. The arborist wants to find the height of the tree, how tall the tree is. So you're trying to measure the tree here without actually having to climb it. This one is neglecting the height of the arborist. There are some questions in the homework where you have to add the height of the arborist because the line of sight horizontal isn't on the ground. All right, so this one is neglecting everything from the ground up to the line of sight of the observer. We have this here is the triangle, the 50 feet away of the arborist. The angle that was measured was 30 degrees, and we're trying to find the height of the tree. The function that we could use here is the tangent function. So we multiply both sides by 50 here. The tangent is opposite over adjacent. And then we can plug this into a calculator. But actually, 30 degrees is a standard angle, so we know this. We know that the tangent of 30 degrees is the square root of 3 over 3, which means that x is actually just 50 square roots of 3 over 3, and that's approximately equal to 28.9 degrees. We have a surveyor here who wants to find the distance across a lake. he uses the theodolite to take the measurements shown in the figure. Use these measurements to determine how far it is across the lake. So we're trying to find how far it is across this lake. And the surveyor has measured a 40-degree angle here, and he's 400 or 640 yards away. So from 640 yards, let's see. So once again, we have the opposite side and we have the adjacent side, but it's a 40-degree angle this time. So we're going to use the tangent. And the tangent of 40 is y over 640. We multiply both sides by 640, and we get that x is approximately 537.